In this video, we are going to solve the 2019 GCE Mathematics Paper 1 question number 16. This was on the assignment. If you are part of the Euclide Academy online classes, this was on the assignment we had. And if you're not part of the class, you can also join and become part of the class. So what we were doing in this assignment was answering the question from 2019, that is GCE. It was from paper 1, and the question said, in the diagram below, A, B, C, D, and E are points on the circumference of the circle with center O. DE is equal to AD, and angle ACB is equal to 20 degrees, and angle AOE is equal to 80 degrees. So definitely, as we can see, this question is on circle theorems or circle geometry, and we discussed a lot of theorems of circle geometry theorems, and we mentioned a lot of them for us to understand how to solve this question in class if you are part of the online classes. And we mentioned we did a couple of examples. So let's go directly into solving this question. So the question said, find ADE, B find DAE, and C find BAD. So we have to understand a couple of theorems for us to be able to find questions of circle geometry, or to solve questions of circle geometry. So we've got points. First of all, as you're solving problems of circle geometry, look at points which are on the circle. So you've got A here, you've got B, you've got C, you've got D, and you've got E. And then you look at the chords, look at the patterns, so that you can make sense of the theorems. So we have a chord here, AE is a chord, AB is a chord, BD is a chord. So we've got different chords, and we can use all of these, what is happening inside, to be able to come up with, to make sense of the questions here, so that we can easily solve them. For example, if the center, then we know that from the center to, let's say, A here, this is radius, right? This is a radius. So from here up to there, that's also a radius. So we know that these things are equal. Okay, so we also have been given that angle ACB, which is from A, C, B, they've given us 20 degrees there. And then angle AOE, which is A or E, we can see we've got 80 degrees there. And DE is equal to AD. So we say DE is equals to DE is equals to AD. So we can make use of all of this to be able to solve the questions. So find ADE. We've got ADE. So we can use the theorem number 1 for circle geometry, which we discussed, problem theorem number 1. We can call it theorem number 2 or whatever we want, but we'll just say number 1. This theorem states that when it comes to circle geometry, an angle subtended at the center of the circle is equal to twice the angle subtended at the circumference. I'll repeat that one. An angle subtended at the center of the circle, which is here, is equal to twice the angle subtended at the circumference of the circle. So this point here is the circumference of the circle. This is the center of the circle. So the angle which is subtended here. So what is to subtend an angle? I think we definitely did define what subtended means in class, and we know what that means. So this angle subtended here is equal to twice the angle subtended here, which is the circumference. So if we want to find the angle ADE, which is angle A here, and then we have D and E, we just have to find, since this angle is equals to twice this angle here, so we have to just get the half of this to get that angle there. So our angle ADE is going to be 40 degrees, but you can just go ahead and write ADE is equal to 40 degrees. Well, that is correct, but solving it is not giving us any information, and there's no proof that you actually did find the solution. Maybe you copied from someone. So you need to be able to give to show your work in a way that actually proves to the one who's marking your work that you understand what you're doing, and you were not just copying from somebody else. So for example, for what you can say, because this is a mistake most of students make, they're just going to write, they find the answer in their head, solve it mentally, and then just write it down here. That is wrong. You need to show your working, you need to show your reasoning. So here you can say angle ADE, this angle is equal to half of angle E or A or E. So you say half of angle A O. So we put this one there since we're talking about angles A. So angle ADE is equal to half of angle A or E, and then you say therefore angle ADE will be half of, or half times angle AOE, which is 80 degrees. So you can cancel this one there and that one there, and that is 40. So this one will come here and you say angle ADE is equal to 40 degrees. So we put 40 degrees there. So that was the solution for angle ADE. Let's jump to B. Angle DAE, angle DAE. Now you look at the shape which has been formed here. So we're talking about DAE. This looks like a certain shape that we know. And what shape is this? This is definitely a triangle, and we know that the angles in a triangle, they add up to 180 degrees. And we already know one angle here, that it is 40 degrees from calculating. This is 40 degrees here. So if that is 40 degrees, then this angle plus that angle plus 40 degrees should give us 180 degrees. But the thing is, this line and that one there, they are equal. So this triangle is a type which we call an isosceles triangle, which has got two sides which are equal. So in a triangle, if two sides are equal, it means the angles which are here and this one here, they are also equal. So if this one is x, this one also will be angle x. So if you add x plus 40 plus this other x, they should give you what? They should give you what? 180 degrees. So you can say, so this x here, we'll say it's angle DAE, which is DAE. This is what they want. So we're just going to put x for now. So we'll just say, if I say x plus 40 should give me 180 degrees, since we are talking about a triangle here, angles in triangle. So we should be 2x, x plus x is 2x plus 40. This should give me 180 degrees. So we can, this is basic algebra, we can subtract 40 degrees from both sides, or we can get this 40 degrees and put it on the other side, and it becomes a negative, whichever reasoning you use. So minus 40, and then this becomes 2x is equals to 180 minus 40, it becomes 140, and then you divide this by 2 and we divide that by 2, and we say x here is equals to 40 divided by 2, and we get 70 degrees. Okay, wonderful. So that means angle DAE is equal to 70 degrees. and then find angle BAD. So this is where most of us kind of got stuck, because this was 1 mark and this was also 1 mark, and this one was 2 marks. So let's find the angle BAD, angle BAD, which is BAD, this one right here. Okay, so for us to find angle BAD, we need to use a couple of theorems, apart from the one which says that the angle subtended at the center is twice the angle subtended at the circumference. So the theorems which we are going to tap into for us to solve this one, we'll use the theorem which says that angles subtended by the same chord are equal. So we are going to use the chord AB. This line is known as a chord. This is a chord. If you are in, and once again, I would advise you to be part of our online classes if you are not yet, you haven't yet done that, to join us and we work on these together so that we will learn on this together. So if you understand, this is called it's known as a chord, just not to mix up words there. This is known as a chord AB. So AB subtends this angle right here, which is BDA, this angle right here. So I'm going to put it in a different color. So this angle, the small angle right here, it is this one here. This is BDA. So again, this same chord subtends angle ACB, which is 20 degrees. So which means this angle ACB is equal to the angle ADB, because these angles are coming from the same chord. And you really have to think about this when you're solving these problems, and they become easier for you. So this is this angle comes from these 2 points, and as well as this angle you see, they're coming from the same chord. This AB line is like the parent of these angles, so they are all equal. So which definitely tells us that angle, if this is 20 degrees, this one right here will also be 20 degrees. So we haven't solved the question yet. We just we definitely own one piece of the puzzle here, which is BDA is 20 degrees. Now what we want is not BDA but BAD. So this is BAD. So if you know what we are looking for here, we can rightfully say it is this one here. This is BAD. So again, you need to make sense of the figures that we have here. If you look at A, B, D, what shape is this? A, B, D is a triangle, and we know that angles in a triangle add up to what? 180 degrees. So if you add this 20 plus this angle right here plus the angle we're looking for, which is BAD, it should give us 180 degrees. But the problem is, yes, we have this one as 20 degrees on D. On B, we don't know what the angles add up to. Well, what angle is here. So I'll just put it in a different color here. So let me just put it in blue. So this angle here on ABD, we don't know it. If we knew this angle, we could add this, add that, and then add this unknown here, and then equate everything to 180, and we will find for this angle here. That will be easy. But if we don't know this B, but is there something which can help us to find the B? Definitely. The X angle here, we said it is 70 degrees, right? So this X here is equal to 70 degrees. So I hope we are following here. So I'll try to be slow so that we are together. So this is 70 degrees right here. This angle X here is 70 degrees. So why am I talking about this angle when we want this angle? So the reason why I'm saying this is because we want to use a theorem which says that opposite angles opposite angles of a cyclic quadrilateral add up to 180 degrees. So what is a cyclic quadrilateral? So if you have got 4 points resting on the circumference of the circle, like the way we have A, B, D, and E, and then these points have been joined together, 4 points. So quad, we're talking about 4 points here. So these make this figure inside the circle, and this figure inside the circle is what we call a quadrilateral. So the opposite sides of this quadrilateral add up to 180 degrees, the opposite sides. So meaning this side here is opposite to this side is opposite to that side. Okay, so there are two ways in which we can find this angle BAD, I think. So we can use this one right here and this, or we can use this one and that. So it depends which one we want to use. So let's try to use both ways if we can come up with the same answer. So this is 70 degrees right here, and then what we're going to say is, since the opposite sides of a cyclic quadrilateral, they add up to 180 degrees, so you're going to say 70 degrees plus this 70 degrees here plus the angle on B here, which we don't know, so we say this is angle D, B, A. This should give us 180 degrees. So we therefore know that angle D, B, A will give us 180 degrees minus 70 degrees. And this definitely will give us 110 degrees for angle D, B, A. So this green angle here is 110 degrees, which is angle DBA. So having angle DBA and angle ADB, which is 20 degrees, gives us the information we need to solve for angle DAB. So we have angle, let's say angle BDA is 20 degrees, angle A or DBA, which is this one, is 110 degrees. If we add these two angles plus angle BAD, we're going to get 108 degrees. So I'm just going to make some space right here, and then let's solve for that so that we see what angle are we getting for BAD. So we have got angle. So you have to show how you're coming up with all this by putting it as we've done here. So you say angle BDA plus BDA, you know it is BDA, so we're talking about this one at 20 degrees. So you follow the letter which is in the middle right here, that's why your angle is 20 degrees, plus angle, we say ABD, ABD, or we say DBA. Since we have started with DBA, we're going to go with DBA, which is DBA. So we say DBA plus angle BAD, which is BAD. This should give us 180 degrees. So we know BDA is 20 degrees plus angle DBA, we said it's 110 degrees, and then this should give us 108. Sorry, kind of in a hurry there. So we add angle BAD, we should get 180 degrees. So if we add 20 plus 110, we get 130, and then we can put BAD on this side, and then we can subtract 1 30 from 180. So this is the 130 which was here, so we just took it to the other side, change the sign from a positive to a negative, and then the angle BAD is equals to 180 minus 130, that is 50 degrees. So this is our angle BAD. Angle BAD is equals to 50 degrees. So this is one way of finding this angle. And the other way you could have got this angle was by you could have used these opposite angles of the cyclic quadrilateral. This is 40 plus 20, you get 60 degrees, right? So you get 60 degrees. So you can add this to here. We've got this angle right here is the one we want. So if we add this angle, which is BAD plus this x here, which is 70 degrees, this should give us 180 degrees. Since we're using the theorem which states that the opposite angles of a cyclic quadrilateral add up to 180 degrees, so it should be 60 plus 70, that will give us 130 degrees plus BAD, and then that is angle there, and then this should give us 180. So we can put BAD this side, and then this will be 180 minus 130, which comes this side, and then this still gives us the answer as 50 degrees. 50 degrees as the final answer. So that is a very horrible 50, but 50 degrees as the final answer. So BAD is equal to 50 degrees. So we could have used this way or this way. So I don't know, you choose which way makes sense, but it all depends with which theorem is next to you, is under your fingertips. So whichever theorem you feel like is easier for you, you can use that one. This was a bit longer compared to this method here, but they'll give us the same answer. So that was on the 2019 GCE paper 1, question number 16 on circle theorem. So these were our answers. So just to summarize, here we use the theorem. On this one, we use the theorem that the angle subtended on the center is equals to twice the angle subtended on the circumference. And then for this one, we use the theorem that angles subtended by the same chord are equal. And for the last one, we use the theorem which says that the opposite angles of a cyclic quadrilateral add up to 180 degrees. So if you want more in-depth lessons on this, you can be part of the classes. So we'll see you on the next video.